Hello, and welcome to this video on the required practical component characteristics. This is for GCSE Physics and Combined Physics. The equation that can be used to calculate resistance is V equals IR, potential difference equals the current times the resistance. So to find the resistance of a component, the potential difference and the current have to be measured. The resistance can then be calculated by using the equation above. This is the circuit for gathering this data. The ammeter is in series, it measures the current going through the component. The voltmeter is in parallel with the component as it measures the difference in potential to do work, so needs 2 points to compare. You also need a variable resistor in the circuit to vary these readings so you can get multiple readings in an investigation. Take readings of current and potential difference and substitute them into the equation to calculate the resistance of the component. Using this circuit, data can be gathered and plotted. To get data in the negative direction, reverse the power supply. Different components have different characteristic graphs. You need to be able to match the shape of the graph to the components and be able to explain the shape. This circuit is set up for a fixed resistor. If you swap this for a filament lamp or a diode, you can get data for those components. This is an IV graph for a fixed resistor. Its characteristic shape is a straight line that goes through the origin. This shows that the current and the potential difference are directly proportional. This type of graph shows that the component is an ohmic conductor. That's one that obeys Ohm's law. Ohm's law is that the current and the potential difference are directly proportional as long as the temperature remains constant. This circuit is set up for a filament lamp. This is a graph plotted from data gathered from the circuit above. This is the characteristic shape for a filament lamp. It's not directly proportional as it is curved. This shows that it does not obey Ohm's law and so is non-ohmic. The graph curved because the resistance of the filament lamp changes. This happens because the lamp gets hotter and therefore the lattice ions in the wire vibrate with greater amplitude. A greater frequency of collisions with the electrons is now possible and this reduces the current. This circuit is set up for a diode. A diode will only allow current to flow in one direction. This is a graph plotted from data gathered from the circuit above. It is the characteristic shape for a diode. It is not directly proportional as it is not a straight line that goes through the origin. This shows that it does not obey Ohm's law and so is non-ohmic. The graph has this shape because the diode has a really high resistance in the negative direction. No matter how high the potential difference is, no current will flow in that direction. If the current is in the positive direction with respect to the diode, then current will flow once a threshold voltage has been passed. After this, the current will increase with the potential difference. And that's all for this video. Thank you so much for listening.